Hello, my dear students. Welcome to the second lecture of electric charges and fields. Today, we will discuss the MCQ questions from the topic of Coulomb's law. So, here in question number 18 from the MTG fingertips. So, here what it says, Coulomb's law relates two charges and distance between them, describing the electric force as being. That means, here in this particular, what it is saying is that Coulomb's law, जो कि यहाँ पे दो चार्जेस को लेके या फिर उनके बीच में जो डिस्टेंस है उसको लेके इलेक्ट्रिक फोर्स को कैसे डिस्क्राइब कर रहा है. क्लियर. सो हियर व्हाट इट इज सेइंग इज दैट फर्स्ट ऑप्शन इट इज सेइंग proportional to the sum of the charges. That means force between the two charges is proportional to sum of the charges q1 plus q2. So I think it is wrong. And similarly, inversely proportional to the distance. Second bit, it is saying inversely proportional to the distance between the charges. That means force is inversely proportional to distance between the charges, and it is also, I think, wrong. And proportional to the product of charges and inversely proportional to the distance. Proportional to, that means the force between the charges is proportional to product of the charges. Let charges be q1 and q2, and inversely proportional to distance between them. So I think here it is also wrong. And finally, what is saying, proportional to the product of charges and inversely proportional to the square of distance. That means here force is proportional to the product of charges and inversely proportional to the square of distance. So this particular this particular statement will be the correct one. Why? Because what actually Coulomb's law tells us is that force between the charges is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of distance between them. So here option D will be the correct one. Next, in question number 19, which of the following statement is true about electric force? So इलेक्ट्रिक फोर्स के बारे में कौन सा स्टेटमेंट यहाँ पे सही है वो हमें यहाँ पे चूज करना है. सो हियर व्हाट इज सेइंग, इलेक्ट्रिक फोर्सेस आर प्रोड्यूस्ड बाय इलेक्ट्रिक चार्जेस. ओके, फोर्सेस जो होता है इलेक्ट्रिक फोर्स. क्लियर. फोर्स जो यहाँ पे कौन सा नेचर है उसका, इलेक्ट्रिक इन नेचर. क्लियर. तो ये कौन प्रोड्यूस कर रहा है, चार्जेस. ओके. सेकेंड, like charges attract and unlike charges repel. Like charges means positive and or you can say negative. Similarly, unlike charges means positive negative or negative positive. Clear. So here what is saying, like charges, that means plus or minus they will attract. So I think it is wrong. Like charges repel and unlike charges attract. Electric forces are weaker than gravitational force. It is also a wrong statement. Electric forces are quite stronger as compared to the gravitational forces. And what is the relationship between them? For example wise, here if we take two protons, then there will be as protons are positively charged particles, that means there will be electrostatic force between them. And similarly, as they are having some mass. Clear. That means they will be having gravitational force. So here in this particular case, we must remember that the electrostatic force between two protons is approximately equal to 10 to the power 36 times the gravitational force between them. Clear. So electrostatic force between two protons is 10 to the power 36 times the gravitational force between them. Clear. So that's why that means we must remember here that electrostatic forces are quite strong as compared to the gravitational force. So next is, that means option C will be the incorrect one. Positive and negative charges can combine to produce a third type of charge. That means suppose here if you take two positive charges and if you combine them with negative charge, that might give some any other kind of charge, then it will be a wrong statement. Clear. Because there are only two kinds of charges, one is positive and another is negative. Clear. So finally option A, what is saying, electric forces are produced by electric charges. That is a correct statement. Why? Because generally this kind of force, electrostatic forces or electric forces, are generally exist in between the charges. So that's why these charges generally generate or produce this kind of electrostatic force. So option A will be the correct one. Okay, in question number 20, what it's saying is that the constant k in Coulomb's law, the constant k in Coulomb's law depends upon, first option what is saying, nature of medium, system of units, intensity of charge, D both A and B. So let us first write what is Coulomb's law. So Coulomb's law, what it says is that force between the charges q1 and q2 is directly proportional to the product of the charges and inversely proportional to the square of the distance between them, and from there we can write F is equal to k q1 q2 divided by r square. And this and in this particular question they are saying about this particular constant, and the value of that constant k is 1 upon 4 pi epsilon naught, and this is epsilon naught. The epsilon naught, it is nothing but permittivity of free space, and if it is a given medium, then in that particular case the constant k will be nothing but 1 upon 4 pi epsilon naught epsilon, and this epsilon is nothing but permittivity of the given medium, okay. So fine, here in this particular case, this particular constant it depends upon, this k depends upon what, it is inversely proportional to the permittivity of the given medium. That means here it generally depends upon the, and this permittivity, and what does this permittivity, ये मीडियम के ऊपर डिपेंड करता है. कौन सा मीडियम यहाँ पे फ्री स्पेस के लिए एप्सिलॉन नॉट, अगर गिवन मीडियम है तो उस वाले पर्टिकुलर केस में ये एप्सिलॉन को हम लिख सकते हैं एप्सिलॉन नॉट इनटू एप्सिलॉन आर, और एप्सिलॉन आर इज द रिलेटिव परमिटिविटी. क्लियर. सो यहाँ पे इस वाले पर्टिकुलर केस में हमें यहाँ पे ध्यान में रखना है कि दिस परमिटिविटी एक्चुअली डिपेंड्स अपॉन द मीडियम, कौन सा मीडियम हम ले रहे हैं, तो उसके हिसाब से ये एप्सिलॉन का वैल्यू वहाँ पे चेंज होगा, और ये एप्सिलॉन का वैल्यू अगर वहाँ पे चेंज होता है तो k का वैल्यू वहाँ पे चेंज होगा, बिकॉज 4 pi इज कॉन्स्टेंट. क्लियर. सो हियर इन दिस पर्टिकुलर केस नेचर ऑफ मीडियम, दैट मीन्स ऑप्शन ए विल बी द करेक्ट वन. Second is it is saying about system of units. Here in this particular case, by applying the concept of system of units, we can calculate the unit and dimensional formula of k. Clear. But here it is asking what upon what it depends, किसके ऊपर ये डिपेंड करता है. सिस्टम ऑफ यूनिट्स के ऊपर ये डिपेंड करेगा ऐसा कोई मतलब जरूरी नहीं है. it depends, actually it depends upon the formula wise, it depends upon the given physical quantity which is the permittivity of the medium. इंटेंसिटी ऑफ चार्ज, तो चार्ज का तो यहाँ पे कोई क्वेश्चन ही नहीं आ रहा है. देयर इज नो चार्ज प्रेजेंट इन दिस पर्टिकुलर फॉर्मूला, सो इट इज ऑल्सो नॉट. सो बोथ ए एंड बी, एंड आई थिंक it will not be. In some cases system of units might be there, but the most appropriate answer will be the nature of medium. Okay, next in question number 21, which of the following statement is not a similarity between electrostatic and gravitational force. यहाँ पे जो स्टेटमेंट में स्टेटमेंट क्वेश्चन है कौन सा यहाँ पे सिमिलरिटी शो नहीं कर रहा है. which of the following statement is not a similarity between electrostatic and gravitational force. Okay, fine, we'll check. Both the forces obey inverse square law, similarity is there, because yes, inverse square law, that means inversely both the forces are inversely proportional to the square of distance, so this is known as inverse square law. Both laws are inverse square laws. Both the forces operate over very large distance, yes, that is also true. That means both the forces generally that means in both cases if you calculate the force, then force can be calculated till force, that means force between the two given objects, two given charges will be zero at infinity only. Clear. So we can calculate up to infinite distance. Clear. Infinity में तो जीरो होगा, तो infinite तक हम जा सकते हैं, force calculate कर सकते हैं. Clear. तो ये भी सही होगा. Then both the forces are conservative in nature, that is also true. Both electrostatic force and gravitational force are conservative in nature, that's why we can define the energy for the corresponding forces, for the given forces. Clear. Okay, so this statement is also true, and both the forces are always attractive in nature. Clear. So here in this particular case this will be a wrong statement. Why? Because electrostatic, in case of electrostatic force we will get either attractive or repulsive. Clear. The force might be either electrostatic force, electrostatic force might be either attractive or it might be repulsive. Clear? But gravitational force between two masses, generally it is taken between two masses, is always attractive. कोई भी दो मास आप ले लो, उनके बीच में जो फोर्स रहेगा वो दैट फोर्स विल बी ऑलवेज अट्रैक्टिव इन नेचर. Okay, next here in question number 22, what is saying is that the force between two small charged spheres having charge 10 to the minus 7 coulomb and 2 into 10 to the minus 7 coulomb, 2 into 10 to the minus 7 coulomb, placed 20 centimeter apart in air is. So what are the charges given? The given charges are, let q1 equal to 10 to the power minus 7 coulomb, and q2 is given 2 into 10 to the power minus 7 coulomb. So, and the distance of separation between them is 20 centimeter, that means 20 into 10 to the power minus 2 meter. Then what is the force between them? So F equal to, we know that K q1 q2 divided by r square. The value of K, what is the value of K? K is nothing but 9 into 10 to the power 9 Newton meter square upon Coulomb square. So if we put all this value, 9 into 10 to the power 9, q1 is 10 to the power minus 7, q2 is 2 into 10 to the power minus 7, all divided by 20 into 10 to the power minus 2 whole square. So finally here in this particular case, the value of F will be coming out to be, if we solve this one, so 9 into 2 into 10 to the power 9 into 10 to the power minus 7 to 10 to the power minus 7 all divided by, this particular one will be, this will be 400 into 10 to the power minus 4. Clear? So if we calculate, so how much it will be coming? So 2, this will be 200. So finally, so it will be 9 into, so here if you take 10 to the 4 in to the numerator, so how much it will be? So 9 plus 4, so it will be 10 to the power 9 plus 4 minus 7 14 minus 14 all divided by 200. So approximately this particular value will be 9 into 10 to the power this is 13 minus 14, so 10 to the minus 1, 10 to the power minus 1, and here 2 into 100, that means 10 to the power 2, so it will be 10 to the power minus 2 divided by 2. So it will be 9 divided by 2, that is 4.5 to 10 to the power minus 3. Clear? So the force will be 4.5 into 10 to the minus 3. So 4.5 10 to the minus 3, 5.4 will not be there, so 4 10 to the minus 3. So option B will be the correct one. Okay, next in question number 23, what it is saying is that the nucleus of helium atom contains 2 protons. Okay, fine. So here it has already given the information that there are 2 protons in a given nucleus of helium atom that are separated by a distance of 3 into 10 to the minus 15 meter. So distance of separation that is given 3 into 10 to the power minus 15 meter. Okay, 2 protons, that means both are having equal charge, that means q1 equal to q2 equal to charge of proton is 1.6 into 10 to the power minus 19 coulomb. Okay, so if it is the case, then what is saying, the magnitude of electrostatic force that each proton exert on the other. Here, so one proton that will exert an electrostatic force upon the other is how much? So that force will be nothing but k q1 q2 divided by r square, but both are having same magnitude, so k q square upon r square. So here in this particular case, Okay, so fine, it will be 9 into 10 to the power 9. Q is 1.6 into 10 to the power minus 19 whole square divided by r square. R square is 3 into 10 to the power minus 15 whole square. So this particular value will be 9 into 1.6 into 1.6 into 10 to the power 9 into 10 to the power 9, 10 to the power minus 19 its square. That means 10 to the power minus 38 all divided by 9 into 10 to the power minus 15. That's its power is 2, so that means it will be 10 to the power minus 30. So finally 9 got cancelled, so 16 is 256. So 256 divided by 100, so it will be 2.56 into 10 over 30. If we take it to the numerator, so how much it will be coming? So 10 to the power 9 minus 10 to the minus 9 minus 38 plus 30. So it will be 2.56 into 10 to the power 9 minus 8, that is 10. So it will be 25.6. Clear? That means the force will be 25.6 Newton, 25.6. So 25, option B will be the correct one. Okay, next moving to question number 24. Two insulated charged metallic spheres P and Q have their centers separated by a distance of 60 centimeter. Two insulated metallic spheres. So what it's saying is that there are two insulated metallic spheres. There are two insulated metallic spheres. Their centers. These are the centers, and the distance of separation from their centers it is given, and that value is how much? That is given 60 centimeter. Okay. So, pairs are P and Q. Okay, fine. The radii of P and Q are negligible compared to the distance of separation. Okay, fine. Radius, let it be R1 and R2, and these two radii are very, very negligible. So you can neglect them. The mutual force of electrostatic repulsion, if the charge on each is 3.2 10 to the minus 7 Coulomb. So charge on each is how much it is given? Charge on each, so charge on each is 3.2 into 10 to the power minus 7 Coulomb. So P sphere is having charge 3.2 10 to the minus 7 Coulomb. Q metallic sphere is also having charge of 10 to the minus 3.2 into 10 to the minus 7 Coulomb. That means both the charges are having Q1 equal to Q2, and that value is how much? 3.2 into 10 to the power minus 7 Coulomb. Okay, fine. The mutual force of electrostatic repulsion will be how much? Clear? So force of repulsion, that means distance of separation is given how much? That will be taken as 60 centimeter. Why? Because these two metallic sphere will be considered as point object. These two, as distance between them is quite large as compared to the radius, and it is saying is that the radius is negligible. So that means here in this particular case, what we'll do, we'll consider these two spheres as 2 point objects. Clear? So if we consider, that means P and Q will be considered like this, and distance of separation between them will be taken as 60 centimeter. Okay, this will be the case. Then force between them, what will the force between them? The force between them will be F equal to K Q1 Q2 divided by R square. The value of K is nothing but 9 into 10 to the power 9. 9 into 10 to the power 9 into Q1 is 3.2 into 10 to the power minus 7 into Q2 is also same, 3.2 into 10 to the power minus 7 all divided by distance. It is given 60 centimeter, that means 60 into 10 to the power minus 2 meter. 60 into 10 to the power minus 2 square. Okay, so if we do the calculations, so how much we'll get? 9 into 3.2 into 3.2 into 10 to the power 9 into 10 to the power minus 14 all divided by, this will be 3600 into 10 to the power minus 4. So finally here we'll get, so 9 4 is 36 and 4 into 0.8, it will be, so finally how much we'll get at the end, it will be 0.8 into 3.2 all into 10 to the power 4, that will go to the numerator, so it will be 10 to the power minus 4, so it will 10 to the power 4, so 10 to the power 9 minus 10 to the power 10, so it will be into 10 to the power minus 1, 10 to the power minus 1 and divided by 100, that means 10 to the power minus 200 in the denominator, so 10 to the power 2, and if it goes to the numerator, so it will 10 to the minus 2. So finally how much we will get, we will get here, so 0.8 into 3.2. So here this will be 0.8, that means 8 into 32, that means 8 into 32 is 256 divided by, here it will be divided by 10, that is 100, that means 2.56. So it will be 2.56 into 10 to the power minus 3. So this will be the final, this much Newton. So 2.56, so 5.2, 2.5, 2.5, 10 to the minus 3. So option B will be the correct one. Okay, next question number 25. 2-point charges of 3 microcoulomb and 4 microcoulomb repel each other with a force of 10 Newton. So given charges Q1 equal to 3 microcoulomb and Q2 is how much, 4 microcoulomb. Clear? So 3 microcoulomb is 3 into 10 to the power minus 6 coulomb, and it is 4 into 10 to the power minus 6 coulomb. Okay, and the force between them is coming out to be how much, 10 Newton. Clear? Okay, this is one case, and in another case, okay, so if it is the force, then here in this particular case what will be the distance of separation between them? Clear? If it is the force, then what is saying, if each is given an additional charge of minus 6 microcoulomb, the new force is. Clear? So that means let the distance of separation between them is r. Clear? Let r is what, r is the distance of separation, distance of separation between the given charges. Clear? So that means the system, let the system to be like this. This is one charge and this is one charge, this is 3 microcoulomb and this is 4 microcoulomb, and these two are separated by some distance, let it be r. Clear? And the force between them, that means both are positive, that means both will repel each other. Force between them is coming to be how much, 10 Newton, and here 3 microcoulomb will repel the 4 microcoulomb charge with a force, with the same force, that is 10 Newton. Clear? And right now what it is saying is that in the same system, if each is given an additional charge of 6 microcoulomb, तो ये जो चार्ज 3 माइक्रोकूलम है उसमें ये जो चार्ज 3 माइक्रोकूलम what is given over here. So here let me copy that one. So if here in this particular case, if each charge is given an additional charge of minus 6 microcoulomb, so here 4 microcoulomb charge is also being added with another charge of minus 6 microcoulomb, then what it is asking, the new force will be, what will be the new force right over here. So that means the new system will be what, so 3 minus 6, that means minus 3 microcoulomb. So that means that new system becomes what, this will be minus 3 microcoulomb, and this 4 microcoulomb will become what, it will become 4 minus 6, that is minus 2 microcoulomb, and there is no change in the distance of separation between the given system. Clear? Then what will be the new force between them? So here in this particular case, if we assume the force in the original system, force in the old system, this is the old and this is new system. Clear? Force in the original system is coming out to be 10 Newton, and its value can be written as q1 q2 divided by r square. So so here this is the case. And similarly, force in the new system, what is the force in the new system? Force, let it be f prime, that has to be calculated, and let that value be q1 prime into q2 prime divided by distance square. Clear? So here in this particular case, if we take the ratio of these two forces, then what will get? So f upon f prime will be how much? So here q1 q2, f is q1 q2 divided by r square whole divided by q1 prime into q2 prime divided by r square. So r square will get cancelled out. So q1 q2 divided by q1 prime into q2 prime. So what is the value of q1 q2? The value of q1 q2 is 3 and 4. So this is 3 into 4 divided by, this is minus 3 into minus 2. So how much will be getting? So that ratio will come out to 3 got cancelled, so minus minus becomes plus, so it will becomes 2. So that means the ratio of these two forces upon adding a new charge will become how much? That will be 2:1. Clear? So here in this particular case it will become how much? 2:1. So that means here in this particular case the new force will be original force divided by 2. So original force is how much? 10 Newton it is given, original one, old system. So 10 divided by 2, that means it will be 5 Newton. So new force between the system will be how much? 5 Newton. So option C will be the correct one. Okay, next is here what is saying the ratio of magnitude of electrostatic force and gravitational force for an electron and a proton is. So ratio, so we have to calculate the both electrostatic force and gravitational force between an electron and a proton. Clear? Okay, fine. And it is asking what the ratio between them. So if you take an electron, then then its charge of electron is how much? 1.6 into 10 to the power minus 19 coulomb. And if we take in magnitude wise, clear? And similarly its mass of electron is how much? 9 into 9.1 into 9 point will be 9.1 into 10 to the power minus 31 kg. Clear? Similarly, if we take the case of proton, then in that particular case charge of one proton is how much? Same, 1.6 into 10 to the power minus 19 coulomb, and mass of the proton is how much? 1.6726 into 10 to the power minus 27 kg. Clear? So this is the mass of protons. Okay, if it is given, then it is asking what is the ratio between. Okay, so here in this particular case, assume while calculating the electrostatic force and gravitational force between the proton and electron, let the distance between them is fixed. Clear? Let the distance between them is fixed. That means if this is an electron and this is an proton, and distance of separation between them यहाँ पे हम कितना लेंगे? यहाँ पे r लेंगे. क्लियर? तो ये वाला पर्टिकुलर केस में तो ग्रेविटेशनल फोर्स कितना होगा? व्हाट विल बी ग्रेविटेशनल force between the given proton and electron will be Fg will be how much? So G m mass of electron, mass of proton divided by distance of separation square, because it obeys inverse square law. Clear? And similarly, how can we write the electrostatic force? electrostatic force. The formula for electrostatic force is nothing but F electrostatic. F electrostatic will be nothing but K charge of electron into charge of proton divided by distance of separation square. So if we do the calculation, individual calculations over here, the gravitational force will comes out to be how much? The value of G is 6.67 into 10 to the power minus 11. Mass of electron is 9.1 into 10 to the power minus 31 into mass of proton is how much? Mass of proton is 1.67 into 10 to the power minus 27 all divided by r square. And similarly over here, the electrostatic force will comes out to be 9 into 10 to the power 9. Charge of electron is 1.6 into 10 to the power minus 19. Charge of proton is same 1.6 into 10 to the power minus 19 divided by r square. So here in this particular case, if we take the ratio of these two, that means Fg upon Fe. So it will comes out to be how much? So r square will both cancel out. So finally the value will be 6.67 into 10 to the power minus 11 into 9.1 into 10 to the power minus 31 into 1.6726 into 10 to the power minus 27 whole divided by, it is 9 into 10 to the power 9 whole into 1.6 into 10 to the power minus 19 into 1.6 into 10 to the power minus 19. Clear? So if we do, how will we do the calculation? So 6.67 into 9.1 into 1.67 whole into 10 to the power minus 11 minus 31 minus 27 whole divided by 9 into 1.6 into 1.6 into 10 to the power minus 19 minus 19. So that particular value will be, so if we do the calculations over here, okay, let me check one second whether the properly it is written or not. So 6.67, 9.1, 1.67, 10 to minus 11 minus 31, okay, minus 27, okay, next 10 to 9 minus 19 minus 19, okay, it will be plus 9, 1 plus 9, okay, fine. So finally ratio of this one. So but if we here it is asked to calculate the ratio of electrostatic force upon gravitational force. So what will be that one? So that will be 9 into 1.6 into 1.6 divided by, it will be 6.67 into 9.1 into 1.67, and this particular value will be how much? It will be 10 to the minus 7 plus 1 8 plus 1 9, so it will be 5 plus 1 6, 10 to the minus, so it will be in the denominator part it will be 10 to the power minus 69, and in the numerator how much will be getting? So 90 minus 9, so minus 10, so 10 to the power minus 29. Clear? So finally here in this particular case, if we take exactly, so if we take approximate value, so by taking approximate value, so how much will it be? Let approximately this is 0.97 or 98 like that, and 1.6 and 1.67 nearly approximately that value will take approximately equal to 1, approximately 1. Here also we can take it approximately equal to 1. So finally here over here how much will get? So 1.6 divided by 6.67 into 10 to the power minus 6, that will plus 16 and minus 20, so it will be 10 to the 40. So here 16 by 16 upon 66, let it be approximately 66, approximate, we are taking approximate values, so into 10 to the power 40, so approximately something around how much we'll get? We'll be getting So 16 4, nearly more than this is 4, approximately 4 point something will get. Clear? Approximately 4 point something in the denominator will get. So 1 upon 4, that is 0.25. So it will be 0.25 into 10 to the power 40, or approximately it will be 2.5 into 10 to the power 39. Clear? So approximately this particular value will be 2.5 into 10 to the 39. So let us check the answers. So it will be 2.5, 2.4, 6.6 will not be there, 6.6 will not be there, 2.4, 2.4, 10 to the 39, 29. So option B will be the correct one. Next, moving to question number 27. Okay, so here in question number 27, what it's saying is that the electrostatic attracting force on a small sphere of charge 2.2 microcoulomb due to another small sphere of charge negative charge of minus zero point 0.4 microcoulomb in air is 0.4 Newton. The distance between the two spheres is okay. So what is given? There are two spheres. Two spheres are being bus. The left side sphere, let it be having a charge of 0.2 microcoulomb, and right sphere is having a charge of 0.4 microcoulomb. Here, and this is negative 0.4. Here, so there must be a distance of separation, and let us consider the distance of the separation is taken from the center, and let it be center of the sphere, so let it be r. So what are the given information? Q1 is 0.2 microcoulomb, so that is 0.2 into 10 to the power minus 6 coulomb, and Q2 is negative 0.4 microcoulomb, that is negative 0.4 into 10 to the power minus 6 coulomb. Okay, fine. And force between them is how much? 0.4 Newton. So finally R. So we know that F is equal to K Q1 Q2 divided by R square. That implies R square will be equal to K Q1 Q2 divided by F. So finally, if you calculate, if you put all the values, K is 9 into 10 to the power 9 into Q and is 0.2 into 10 to the power minus 6 into magnitude wise. If we take the value as it is already said that it is an attractive force. Clear? So here attractive force, that means we don't have to put the negative sign over there because we will take magnitude wise. So it will be 0.4 into 10 to the power minus 6 divided by F is how much? 0.4. So finally here in this particular case, how much we'll get? So it will be we'll be getting, so 9 into 0.2 into 0.4 into 10 to the power 6 12 minus 12 plus 9, so minus 3 whole divided by 0.4. So finally the value of r square that we are getting, 9 into 2 into 4 into 10 to the power minus 3 divided by how much? 4 into this will be 4. That means here we'll get how much? 0.4 into 10 into 10. Clear? So here it will be 4. So this 4 and this 0.4 into 10, that will become 4. That will do, this 2 will cancel out. So how much we'll get? So we'll be getting 18 into 10 to the power minus 4. So the value of r square is, if this one, then r will be how much? R will be under root 18 into 10 to the power minus 2. So it will be 9 2. So that means 3 root 2 into 10 to the power minus 2. So 3 root 2 is how much? 3 into 1.414. 3 into 1.414 into 10 to the power minus 2. So if you calculate the value, so it will be 2. This will be 4, 2, and 4. So 4.242 into 10 to the power minus 2. So this will be the correct. So distance of separation is much? It will be in meter. 4.242 43 10 to minus 6 to 10 to minus, okay, 4.242. So this option C and option D will not be, so A 4.24, option C will not be 40, this is 43.2. So if we take, so this will be 42.42 into 10 to the power minus 3 meter. So option B will be the correct one. Okay, question number 28, what it is saying is that under the action of a given Coulombic force, the acceleration of an electron is 2.5 into 10 to the 22 meter per second square. Okay, meter per second square. Then the magnitude of acceleration of a proton under the action of same forces. Okay, so here what is saying is that due to a given Coulombic force, the acceleration of an electron, acceleration of the electron is given how much? It is 2.5 into 10 to the power 22 meter per second square. Okay, and it is asking the acceleration of proton will be what if magnitude of force acting upon both the object is same. That means here we can say force acting on the electron will be same as force acting on the given proton. Clear? So that means how can I write the force? So force is nothing but mass of electron into acceleration of electron, that will be equal to mass of proton into acceleration of proton. Clear? Then the value of what we want to calculate, we want to calculate the acceleration of proton, then AP will be how much? Mass of electron into acceleration of electron divided by mass of proton. So finally if we put all this value, so mass of electron is how much? Mass of electron is 9.1 into 10 to the power minus 31 kg. Acceleration of electron is given, that is 2.5 into 10 to the power 22 divided by mass of proton. Mass of proton is 1.6726 into 10 to the power minus 27. So here in this particular case, how much we will be getting? So approximate values, if we take so 16 into 16, 256, that means here we can take approximately 1.6, let it be approximately 1.61 or 1.601, something like this. Clear? So finally here this particular value will be how much? Will, if we do calculate, so approximately 16 how much? 144. So it will be 14 point, approximately 14.4 into 10 to the power, how much will be getting? Minus 9. Okay, so 14.4 into 10 to the power minus 30, okay, 30 minus 31 plus 22, so minus 9, and here in the denominator it is minus 27, so it will be become plus, so it will be plus 27. Okay, so finally how much will be getting? 14.4 into 10 to the power 10 to the power 18, so 14.4 into 10 to the power 18, so approximately how much will you be getting? 14.4 into 10 to the power 18, so in single decimal, so it will be 1.44, that means approximately take it 1.44 into 10 to the power 19. Okay, so find 1.44 into 10 to the power 19. So 1.44, the approximately you can take 1.5 into 10 to the power 19. So option C will be the correct one. Okay, option C is the correct one. So finally acceleration of the given proton is coming out to be how much? 1.5 or 1.44 into 10 to the power 19 meter per second square. Okay, this will be the final answer. Okay, so here in question number 29, what it is saying is that the acceleration for electron and proton due to electrical force of their mutual attraction when they are 1 angstrom apart. So here what are the there is an electron and there is a proton. Electron and proton both are separated by a distance of how much? 1 angstrom. Then what is asking? The acceleration of the given electron and proton. So here in this particular case, first of all, we need to find out the force between the given electron and proton. So what is that force? That force will be nothing but electrostatic force, and that force, we can also calculate the gravitational force by taking the mass, but as we are going through the chapter of charges and fields, so we'll take the help of Coulombic force. So F will be K, charge of electron, charge of proton divided by distance of separation square, and that value will be 9 into 10 to the power 9 into charge of electron is 1.6 into 10 to the power minus 19. 1.6 into 10 to the power minus 19 is the charge of proton divided by distance of separation is 1 angstrom, that is 10 to the power minus 10 meter whole square. So finally the force will comes out to be how much? So 9 into 1.6 into 1.6, that means 2.56 into 10 to the power minus 38, 10 to the power minus 38 plus 9 whole divided by 10 to the power minus 20, so that will become plus 20. So approximately this will be 9 into 2.56 whole into 10 to the power. So if we do 10 to the power, it is 29 minus 38, so that means it will be 10 to the power minus 9. Clear? So force will be this much Newton. So right now what it is asking, find out the acceleration. Acceleration, how will you calculate the acceleration of electrons? So we know that force is nothing but mass into acceleration, and force acting in both the cases. Here in this particular case, he is asking acceleration as it is a electron, that means negatively charged, proton is positively charged, that means this electron will exert a force on the proton towards it, and that will be attractive, and this proton will attract the electron towards it. Clear? With the same force, magnitude of the force will remain same. Why? Because it obeys the action reaction, that means Newton's third law of motion. Clear? So force here, force on the electron will be same as force on the proton, and that value will be how much? That value will be mass into acceleration. So here in this particular case, force acting on the proton will be written as mass of proton into acceleration of proton, and force acting on the electron will be written as mass of electron into acceleration of electron. Clear? And here in this particular case, Fe equal to this 9 into 2.56 into 10 to the power minus 9 Newton. Then if we do the calculation of acceleration of electron will be equal to Fe upon me. So Fe is 9 into 2.56 into 10 to the power minus 9 all divided by mass of electron is 9.1 into 10 to the power minus 31. So approximately, let we cut this one, so it will be 2.56 10 to the power minus 31, that means plus 31 plus 31 minus 9. So 2.56 into 10 to the power 22 meter per second square. This will be the answer for acceleration of electrons. So 2.56 into 10 to the power 22, 22.56. So this is wrong, this is wrong. This 2.5 approximately this particular value we can take, and 2.5 10 to 18. So 18 will not be there. Similarly, so let's check whether the second is correct or not. So acceleration of proton will be how much? It will be force acting on the proton divided by mass of proton. So force is 9 into 2.56 into 10 to the power minus 9 whole divided by mass of proton is how much? 1.67 into 10 to the power minus 27. So approximately, if we cut this one, this will be 1.6 approximate. Clear? 1.6062 and like that we'll get. So 1.6 into 9, that means 14.4 into 10 to the power plus 27 minus 9, that means 10 to the power 18. So it will be 1.44 into 10 to the power 19. So 1.44, so 1.3 10 to the power 19, 3.2 10 to the power 16. This will not be 1.5 into 10 to the power 19. Okay, this will be the answer. So finally option C will be the correct one. This much meter per second square. Okay, let us now discuss some of the MCQ questions from the topic of Coulombic force between multiple charges. अगर मल्टीपल चार्जेस होगा तो कोलम्बिक फोर्स को हम वहाँ पे कैसे अप्लाई करेंगे, क्लियर. So here the question is two charges q and minus 3 charges are given. Here it is q and minus 3 q fixed on x-axis separated by distance d. Distance d is given. Where should a third charge plus 2q, here this is post charge is how much, plus 2q, be placed from a location of plus q charge is a, location b is location of minus 3q charge is b. That means this negative charge is 3 times the magnitude of this positive charge which is located at a. Clear. This negative charge is having 3 times magnitude as compared to the charge q, and it is negative, such that it will not experience any force. So where will you place this 2q charge such that it will not experience any force? Okay, fine. So what are the possibilities where we can place this 2q charge? So what are the possibilities? So what are the regions where we can keep? So here we can keep this charge in the left of the given system, यहाँ पे हम रख सकते हैं, या फिर हम पूरा का पूरा राइट में भी यहाँ पे रख सकते हैं. क्लियर. सो रीजन नंबर अब ऐसे अगर हम देंगे तो रीजन नंबर region wise, region 1, let in between them be region number 2 and at the right side be region number 3. तो कहाँ पे हम चार्ज को रखेंगे तो उसके ऊपर जो फोर्स होगा वो 0 होगा. क्लियर. So here in this particular case, suppose in region number 1, suppose if we place the 2q charge to be over here, 2q at some distance from a. Here it is said that from a you have to place the charge from a. So if we place the charge from a at a distance of x, then what are the forces that will act on this 2q charge? So here in this particular case, the force that will act, this plus q charge will apply a repulsive force upon this 2q charge, and that repulsive force will be away from the charge, and this negative 3q charge will apply an attractive force upon this 2q charge. That means it will be towards the given charge. Clear. So here there might be a chances that these two forces will cancel out each other. Clear. यहाँ पे net force यहाँ पे हमें 0 मिल सकता है. Clear. Okay, fine. तो यहाँ पे 0 हो सकता है अगर, और वो भी एक सर्टेन लोकेशन पर ही हमें यहाँ पे 0 मिलेगा. अगर इस पर्टिकुलर x डिस्टेंस पर हमें यहाँ पे अगर नेट फोर्स एफ नेट यहाँ पे अगर 0 मिल रहा है 2q के ऊपर, तो अगर हम इस चार्ज को थोड़ा सा भी राइट साइड की तरफ अगर हम इसको डिस्प्लेस करेंगे तो क्या हो सकता है, दैट हियर इन दैट पर्टिकुलर केस it might happen that this repulsive force will be stronger as compared to the attractive force. और अगर हम इस 2q चार्ज को अगर थोड़ा सा भी लेफ्ट साइड की तरफ इधर अगर लाएंगे तो क्या होगा, देन इन दैट पर्टिकुलर केस द अट्रैक्टिव फोर्स माइट बी स्ट्रॉन्गर एज कम्पेयर टू द रिपल्सिव फोर्स. क्लियर. तो ये एक इक्विलिब्रियम पोजीशन यहाँ पे बन सकता है एक्स डिस्टेंस पर, जहाँ पे नेट फोर्स 0 होने का चांसेस है, और हमें वो एक्स का वैल्यू यहाँ पे कैलकुलेट करना है. क्लियर. अच्छा, रीजन नंबर 2, इफ़ वी टेक द रीजन नंबर 2, सपोज हम यहीं कहीं पे अगर हम चार्ज 2q को रखेंगे, सपोज इफ वी प्लेस द 2q चार्ज ओवर हियर, then this plus q charge will repel this one away from it, and this minus q charge will attract this one towards it. That means here there is no chance for these two forces will cancel out, as these two are along the same direction. दोनों same direction पे है तो forces यहाँ पे 0 होने का कोई chances नहीं. Net force will not be 0. So that means region 2 is not a place where you can keep this charge 2q. In region 3, okay, in region 3, suppose if we'll place this 2q charge over here, यहाँ पे कहीं पे अगर मान लो कि हम इस 2q चार्ज को अगर रखेंगे यहाँ पे 2q, तो क्या हो सकता है यहाँ पे पॉसिबिलिटीज. क्लियर. तो यहाँ पे क्या ऐसा हो सकता है कि नेट फोर्स 0 होगा. ओके. सो यहाँ पे देखने की बात यह है कि ये जो 3q चार्ज है which is having magnitude thrice of the q चार्ज. क्लियर. ये जो 3q चार्ज है इसका मैग्नीट्यूड इससे 3 गुना ज़्यादा है. क्लियर. और इसके पास हम ये 2q चार्ज को अगर रखेंगे तो इसके ऊपर जो नेट फोर्स होगा, मतलब नेगेटिव 3q चार्ज विल अट्रैक्ट दिस वन एंड पॉजिटिव q charge will repel this one with a very small force, as it is quite large distance from the plus q charge. Clear. बहुत ही ज़्यादा दूर पर है, इसलिए क्या होगा यहाँ पे नेगेटिव फोर्स, नेगेटिव चार्ज का जो एट्रैक्टिव फोर्स होगा दैट विल डोमिनेट, क्लियर, वो डोमिनेट करेगा रिपल्सिव फोर्स के कम, रिपल्सिव फोर्स है उसका जो वैल्यू है थोड़ा ज़्यादा होगा. दैट मीन्स हियर ऑल्सो there will not be any case or any location where we will get the net force to be 0. So that means here in this particular case we must remember that the charge to be placed to the left of the plus q charge, clear. So here in this particular case, suppose let me draw the figure once again. So here this is q charge and here it is minus 3q charge, and this is location A, this is location B, and where we'll keep this charge, we'll keep this 2q charge at some location P at a distance of x from A, and distance between the two given charges is d. So, so finally net force upon this 2q charge due to plus q will be, let it be F. Then net force on this 2q charge due to minus 3q will be, let it be F prime, clear. So then the value, what is the value of F? The value of F over here, F can be written as k q into 2q divided by distance of separation is x square, and the value of f prime will be how much? K 2q into 3q. अच्छा, ये वाला केस में अगर हम साइन वाइज यहाँ पे लेंगे, मतलब नेगेटिव, मतलब एट्रैक्टिव फोर्स को अगर हम यहाँ पे नेगेटिव से शो करेंगे तो भी ये हो सकता है, क्लियर. बट हम यहाँ पे डायरेक्शन को हैव ऑलरेडी शोन द डायरेक्शन, क्लियर. तो इसलिए हम मैग्नीट्यूड वाइज हम इसको लेंगे. तो देन दिस पर्टिकुलर वैल्यू विल बी हाउ मच? तो डिस्टेंस ऑफ सेपरेशन इज x प्लस डी होल स्क्वायर. ओके, तो यहाँ पे आप देख सकते हो हम कैसे कर रहे हैं. तो राइट साइड वाला साइन कन्वेंशन वाइज हम यहाँ पे क्या लेंगे? द फोर्स विच इज टुवर्ड्स राइट विल बी टेकन एज पॉजिटिव, the force which is towards right will be taken as positive, and the force which is towards left will be taken as negative. भले ही यहाँ पे चार्ज दोनों का पॉजिटिव हो, बट स्टिल वी आर सेइंग showing that one in the negative direction. Why? Because the repulsive force is along negative x-axis and this attractive force is along positive x-axis, and this vector and these forces are vector quantities and it obeys the direction, clear. So it posits the, as it posits the direction, we can show the direction according to the sign as it is, clear. So then what will the net force? F net will be F prime which is positive plus minus F, क्लियर. तो नेगेटिव फोर्स अगर यहाँ पे मैं पहले से ही नेगेटिव दे रहा हूँ तो यहाँ पे नेगेटिव देने का कोई जरूरत नहीं, क्लियर. तो दैट मीन्स द नेट फोर्स विल बिकम जीरो. दैट मीन्स फ्रॉम हियर वी कैन से F prime will be equal to F. Magnitude wise these two values will be same. That means what we can say, so F prime is k 2q into 3q whole divided by x plus d whole square will be equal to k q into 2q whole divided by x square. So 2q k got cancelled, so how much will be getting? And q will also get cancelled, so we'll be getting over here, so we will be getting, so 3x square equal to x plus d होल स्क्वायर. तो 3 को यहाँ पे हम मल्टीप्लाई कर लेंगे या फिर एक्स स्क्वायर को हम न्यूमरेटर में ले जाएंगे इस साइड में, और x प्लस डी को राइट साइड में हम ले जाते हैं. तो फाइनली हाउ मच इट विल बी 3x स्क्वायर इक्वल टू एक्स स्क्वायर प्लस डी स्क्वायर प्लस 2d इंटू एक्स. Okay, fine. So here how much will be getting? So 3x square minus x square, that will be 2x square. 2x square minus 2d into x minus d square, that will become 0. So in this particular case, a is, let a be 2, b equal to minus 2d, and c equal to minus d square. So if we want to find out the roots, so x equal to roots of the equation is minus b plus or minus under root b square minus 4ac whole divided by 2a. So here in this particular case minus b is minus minus of minus 2b plus or minus b square. B square is 4d square, 4d square minus 4ac. 4 into a is 2 into c is minus d square. Clear? So root of that one divided by 2a, 2 into a is 2. So finally, if we get the roots of the equation, it will be 2b plus or minus 4d square plus 8d square under root divided by 4. So here it will be 2b plus or minus, so it will be 4 plus 8, that is 12d square. 12d square, root of 12d square, that means 2 root 3d all divided by 4. So if we take 2 common, so it will be b plus plus or minus, so it will be b plus or minus root 3 d all divided by 2. Clear? So the roots, what the roots we are getting, is b plus root 3d divided by 2, and another one is b minus root 3d divided by 2. B here b, it is not b, it is 2d, sorry, here it will be 2d, because here it will be 2d, and here 2 here, followed by 2a is 2. Okay, that is correct. So it will be 2d, d, here it is d, so finally it will be d, here d. So finally d plus root 3d divided by 2 and d minus root 3d divided by 2. So this value will be positive. Clear? And this particular value will be d minus root 3d. That means obviously this particular value will be negative over here. So the given roots over here. So d plus root 3d and d minus root 3d divided by 2 we are getting. So if we check the options over here, so over here option A is given d minus root 3d divided by 2, and option B is given d plus root 3d divided by 2. Both are present over there in the roots. These two will be wrong. So out of these two, which one will take? So here we must remember that as I've written, this x is positive and x will be coming out to be negative over here. So here already initially we have taken the value of x to be positive. By taking x as positive, we have done all the calculation. That means this x value will cannot be negative. x का वैल्यू यहाँ पे पहले से ही पॉजिटिव लेके कैलकुलेशन किया गया है, तो x यहाँ पे नेगेटिव नहीं हो सकता है. तो ऑप्शन बी यहाँ पे हमें ये करेक्ट ऑप्शन यहाँ पे होगा. दैट विल बी द करेक्ट ऑप्शन. क्लियर? नेक्स्ट, moving to question number 31. What the question number 31 is saying is that consider the charges q, q and minus q placed at the vertices of an equilateral triangle of each side L. The sum of forces acting on each charge. Okay, so what it is given? It is given an equilateral triangle. Okay, equilateral triangle, that means all sides are same, equal. Equilateral triangle of each side is L. Each side is L. So charges are given q, q and minus q. Okay, fine. The sum of the forces acting on each charge. हर एक चार्ज के ऊपर जो भी फोर्स लग रहा होगा उस सभी का फोर्स का सम क्या होगा. ओके, तो हर एक चार्ज के ऊपर इंडिविजुअली कुछ ना कुछ फोर्स लग रहा होगा. क्लियर? तो पहले तो हमें वो फोर्स को पहले शो करना है, फिर उसके बाद हम जो भी कैलकुलेशन होगा उसको करेंगे. क्लियर? तो पहले हम अगर सपोज फर्स्ट इफ वी कॉन्सेंट्रेट ऑन दिस पर्टिकुलर टॉप चार्ज. क्लियर? देन अपॉन दिस चार्ज व्हाट आर द फोर्सेस एक्टिंग. तो ये जो चार्ज यहाँ पे ये वाला चार्ज प्रेजेंट है, दिस ग्रीन कलर चार्ज, दैट विल that what it will do, it will repel this one. Clear? ये उसको repel करेगा because both are positive. And similarly this red color charge, over here at the top here, that will also repel this charge. Clear? एंड ये जो चार्ज रिपेल कर रहा है दैट इज अलोंग द लाइन जॉइनिंग द टू चार्जेस, क्लियर। ये कोलम्बिक फोर्स का एक प्रॉपर्टी है, क्या प्रॉपर्टी है, दैट फोर्स एक्टिंग ऑन द चार्ज विल एक्ट, मीन्स फोर्स विल एक्ट अलोंग द लाइन जॉइनिंग द टू चार्ज, इन दोनों चार्ज को ज्वाइन करने वाला लाइन के अलोंग ही ये दोनों एक्ट करेगा। दैट मीन्स फाइनली both charges are having same magnitude, distance of separation is L, then both forces will be here. If it is F, that means that means Coulombic force, as the Coulombic force obey action reaction rule, that means Newton's third law. So that means both the forces will be magnitude wise it will be same, but direction wise it will be opposite. That means both will cancel over here. ये दोनों यहाँ पे अपने आप का ऊपर जो फोर्स है उसको कैंसिल आउट कर रहे हैं, क्लियर। एज दिस क्यू चार्ज इज आवर मेन फोकस ओवर हियर, तो उसके ऊपर ये जो नेगेटिव चार्ज है ये भी तो फोर्स अप्लाई कर रहा होगा, क्लियर। तो ये जो फोर्स यहाँ पे अप्लाई कर रहा होगा दैट विल बी अट्रैक्टिव इन नेचर, नेगेटिव चार्ज विल बी अट्रैक्टिंग दिस पॉजिटिव चार्ज टुवर्ड्स इट, एंड दिस पॉजिटिव चार्ज ओवर हियर will be attracting, this positive charge over here will be attracting this negative charge towards it, clear। and कितना force attract करेगा with the same magnitude but opposite direction, that means these two forces will also cancel out, ये दोनों force यहाँ पे क्या होगा, cancel out होगा, clear। similarly तो इस वाले पर्टिकुलर केस में अगर हम देखेंगे, क्लियर, तो ये जो Q चार्ज है, Q चार्ज के ऊपर ये जो फोर्स अप्लाई करे, ये जो आपस में जो दोनों फोर्स है ये दोनों कैंसिल आउट हो रहा है, और ये जो Q चार्ज ये जो है जो ऊपर में जो वर्टिसेस वाला जो ऊपर में प्रेजेंट है इसके ऊपर भी जो फोर्स है वो इस तरफ है, क्लियर, और उसको कैंसिल आउट कौन कर रहा है, ये वाला फोर्स, क्लियर। अच्छा, सिमिलरली अगर हम यहाँ पे इस वाले पर्टिकुलर केस में इफ़ वी चेक दिस पर्टिकुलर चार्ज हियर दिस वन, तो इसके ऊपर जो फोर्स ये वाला कुछ अप्लाई कर रहा होगा, क्लियर। ये जो नेगेटिव चार्ज यहाँ पर प्रेजेंट है दिस नेगेटिव चार्ज विल बी अट्रैक्टिंग इट टुवर्ड्स इट, एंड दिस पॉजिटिव चार्ज विल बी अट्रैक्टिंग दिस नेगेटिव चार्ज टुवर्ड्स इट, क्लियर। ये इसके तरफ अट्रैक्ट कर रहा होगा, दैट मीन्स हियर द फोर्सेस विल बी एफ एंड एफ इज। तो यहाँ पे अगर हम ऐसे ही नॉर्मली, क्लियर, नॉर्मली अगर हम इसको ऐसे ही देखेंगे विदाउट डूइंग एनी रिजोल्यूशन ऑफ वेक्टर, विदाउट एनी अप्लाइंग एनी एडिशन रूल्स, क्लियर, देन अगर हम देखेंगे तो ये सम यहाँ पे क्या होगा, सभी फोर्सेस जितना भी फोर्स है इन सभी का सम यहाँ पे क्या होगा, जीरो होगा। कैसे जीरो होगा, ये जो ग्रीन कलर का फोर्स इन सभी का कुछ ना कुछ डायरेक्शन है, मैग्नीट्यूड तो सेम है, ऑल द फोर्सेस आर एक्टिंग, जितना भी फोर्स यहाँ पे एक्ट कर रहा है इंडिविजुअली सब फोर्स का मैग्नीट्यूड तो सेम है बट डायरेक्शन यहाँ पे अलग अलग है, क्लियर। तो उस हिसाब से क्या होगा, ये जो ग्रीन कलर वाला जो फोर्सेस है ये अपने आप को कैंसिल आउट कर लेंगे, और ये जो थोड़ा लाइट कलर वाला ग्रीन जो फोर्सेस है ये अपने आप को कैंसिल आउट कर सकते हैं, और ये जो ब्लू कलर वाला थोड़ा सा जो लाइट ब्लू कलर वाला जो फोर्सेस है ये अपने आप को कैंसिल कर लेंगे जब हम इन सभी को डायरेक्टली ऐसे सम करेंगे। डायरेक्टली हम अगर इन सब को जोड़ेंगे तो क्या होगा, ये सब अपने आप को कैंसिल आउट कर लेगा अपने तरीके से। तो नेट फोर्स इन दैट पर्टिकुलर केस विल बी व्हाट, नेट फोर्स इन दैट पर्टिकुलर केस विल बी जीरो। ये लॉजिकल स्टेटमेंट है, क्लियर। लॉजिकली द नेट force will be zero. So here we have not done any calculation. अच्छा, इसको अगर हम वेक्टर मेथड से सॉल्व करेंगे हियर वेक्टोरियली और वेक्टर मेथड और एनालिटिकली, तो इसको थोड़ा आसान करने के लिए हम लोग क्या करेंगे, ये वाला केस में लेट अस टेक द सेम इक्विलेटरल ट्रायंगल एंड ओवर हियर let this negative charge be present over here and this other positive charges are q and q be present over here. So here in this particular case let us consider this is charge number 1, this is charge number 2 and this is charge number 3, clear. So simply we will not do much calculations, we will simply geometrically यहाँ पे हम लोग इसको रिप्रेजेंट करें। क्लियर? So here in this particular case, if you take charge number 1, which is present at the top, so upon this one, these two charges, these two positive charges, ये दोनों positive charge नीचे जो है ये लोग force apply करेंगे, and that will be attractive one. Attractive means along the line joining the two charges, that means along this one and along this one. Clear? And in दोनों forces के बीच में angle कितना है? 60 degree. So if it is 60 degree, then and these forces are F and F is, and the value of F is how much? K Q square divided by L square, because the sides are L. Clear? So what will the resultant of these two? So resultant of these two will be what? So resultant will be this one. Clear? So what is the resultant value? Resultant value will be F equal to f or f prime is equal to, so it will be f square plus f square, two vectors f and f making an angle of 60 degrees, so f square plus 2 f into f cos 60 degree. So under root of that one, so how much will be getting? So 2 f square plus 2 f square cos 60 is 1 by 2, so root of that one, so 2 get cancelled, so it will be root 3 f, so that one will be root 3 f. Clear? Okay. Similarly over here, if we check on the second charge के ऊपर चार्ज नंबर 1 and 3 यहाँ पे फोर्स अप्लाई करेंगे. चार्ज 1 विच इज नेगेटिव, इट विल अट्रैक्ट, ये इसको अट्रैक्ट करेगा. क्लियर? कितना फोर्स से? F मेन टू वाइज सेम फोर्स से अट्रैक्ट करेगा. एंड जो Q3 चार्ज यहाँ पे थर्ड चार्ज है, थर्ड नंबर, that will repel this one because both are positive like so, and with what force? Same F. तो इनके बीच में एंगल अभी कितना आ रहा है? 120. एंगल इज हाउ मच? 120 डिग्री. देन द रिजल्टेंट विल बी व्हाट? सो रिजल्टेंट विल बी दिस वन, दिस विल बी द रिजल्टेंट. एंड व्हाट विल बी द वैल्यू ऑफ द रिजल्टेंट? अगर इसका वैल्यू हम अभी आप कैलकुलेट करेंगे, देन F2 इसको मान लो. क्लियर? F2 value will be how much? So it will be f square plus 2f square cos 120 degree. Angle between them is how much? 120. So here it will be 2f square plus 2f square cos 120 is minus 1 by 2. So 2f square minus f square, that is f square, so it will be f. So F net force will be f. Clear? अच्छा. Similarly, if we check this third charge, then इसके ऊपर ये जो फर्स्ट चार्ज नेगेटिव चार्ज है, that will be attracting this one, इसको इधर इस तरफ अट्रैक्ट कर रहा होगा. क्लियर? और ये जो पॉजिटिव चार्ज यहाँ पे सेकंड वाला है, that will be repelling this one towards right. क्लियर? राइट साइड की तरफ रिपेल कर रहा होगा. कितना फोर्स से? F एंड F से रिपेल कर रहा होगा. तो रिजल्टेंट विल बी दिस वन. तो ये भी हमें कितना मिलेगा? F ही मिलेगा. क्लियर? सो अभी इस वाले पर्टिकुलर केस में हमें एक चीज़ यहाँ पे ध्यान में रखना है. क्या? कि ये जो F है, क्लियर, दैट F विल बी मेकिंग हाउ मच एंगल विद द वर्टिकल लाइन. मान लो कि एक वर्टिकल लाइन अगर हम यहाँ पे ड्रॉ करेंगे, ये वाला लाइन, इसके ऊपर यहाँ पे कितना एंगल बना रहा है? ये होगा 30 डिग्री. ये कितना होगा? 30 डिग्री. सिमिलरली अगर यहाँ पे भी एक पर्टिकुलर वर्टिकल लाइन हम यहाँ पे ड्रॉ करेंगे, तो इसके साथ ये कितना एंगल बना रहा होगा? 30 डिग्री. क्लियर? तो F का एक कंपोनेंट हमें यहाँ पे कैलकुलेट करना है. वी वांट टू फाइंड आउट वन कंपोनेंट ऑफ दिस पर्टिकुलर F. क्लियर? वो कंपोनेंट अलोंग द वर्टिकल डायरेक्शन. ये जो दोनों F यहाँ पे प्रेजेंट है, रिजल्टेंट Fs, तो इनका कंपोनेंट वर्टिकल डायरेक्शन में कितना होगा? तो वर्टिकल डायरेक्शन मतलब ये वाला डायरेक्शन में हमें F का एक कंपोनेंट चाहिए. तो दैट कंपोनेंट विल बी F cos 30. एंड व्हाट इज द वैल्यू ऑफ F cos 30? F cos 30 is F into cos 30 is root 3 by 2. So that means root 3 F by 2. So that value will be root 3 F by 2. Similarly, over the left, that means second charge का एक वर्टिकल कंपोनेंट अगर हम यहाँ पे कैलकुलेट करेंगे, निकाल लेंगे, ये वर्टिकल कंपोनेंट कितना होगा? ये भी उतना ही होगा, रूट 3f बाई 2. ये भी कितना होगा? रूट 3f बाई 2. दैट मीन्स ओवर हियर अभी हम ये तीनों फोर्स को अभी हम जोड़ सकते हैं, क्लियर, सेपरेटली वी कैन ऐड देम, दैट मीन्स द फोर्सेस अगर हम यहाँ पे देखेंगे, फोर्सेस इन द वर्टिकल डायरेक्शन, वर्टिकली डाउनवर्ड डायरेक्शन में एक फोर्स यहाँ पे है कितना, √3F, एंड वर्टिकली अपवर्ड डायरेक्शन में दो फोर्सेस यहाँ पे प्रेजेंट है, क्लियर, दो फोर्सेस कितना है, एक आपका √3/2F, दूसरा है √3/2F, that means total will be √3F. So these two forces over here, these two will cancel out each other, clear. So that means the sum of all the three forces will becomes 0, clear. So finally here option D will be the correct one. Okay, next in question number 32, what is saying is that a charge q is placed at the center of the line joining the 2 point charges. Okay, so charge q, that means this particular charge is an unknown charge, clear. This is what, this is a unknown charge, and this plus q, these are what, these are known charges, clear. The ratio of q and q is, इन दोनों का रेशियो कितना होगा, क्लियर. सो हियर इन दिस पर्टिकुलर केस हाउ टू सॉल्व दिस टाइप ऑफ क्वेश्चंस, क्लियर. तो नॉन चार्जेस, दो नॉन चार्जेस रहता है और एक अननोन चार्जेस रहता है, और अननोन चार्ज को जनरली यहाँ पे अगर बीच में रखेंगे तो इसका मैग्नीट्यूड या फिर वैल्यू कितना होता है, इसको हम कैसे कैलकुलेट करेंगे. तो यहाँ पे दो तरीके का क्वेश्चन बनता है कि अननोन चार्ज को कहाँ पे रखा जाता है, फाइंड आउट द वैल्यू ऑफ x, क्लियर. तो जब हम अननोन चार्ज का लोकेशन, वेन एवर वी वांट टू फाइंड आउट द लोकेशन, जब हम लोकेशन ढूंढते हैं तो उस केस में जो ट्रिक हम अप्लाई करते हैं, फोर्स ऑन द अननोन चार्ज मस्ट बी टेकन एज 0, क्लियर. एंड जब हम मैग्नीट्यूड ढूंढते हैं, whenever we calculate the magnitude of the unknown charge, then in that particular case force on any of the known charge, कोई भी एक नॉन चार्ज जो होगा उसके ऊपर नेट फोर्स को हम 0 करते हैं, क्लियर. जब लोकेशन ढूंढेंगे, whenever we find out the location, then force on the unknown charge should be 0, and whenever we want to calculate the magnitude of unknown charge, then in that particular case force on the known charge should be taken to be 0. तो कोई भी एक नॉन चार्ज हम लेंगे, मान लो कि ये वाला नॉन चार्ज हम ले रहे हैं, तो इसके ऊपर नेट फोर्स को हमें 0 करना है, क्लियर. So net force on this particular charge, net force on this q charge on right side should be 0. That means इसके ऊपर फोर्स कौन कौन अप्लाई करेगा, एक तो q और दूसरा ये प्लस q. So that means that will be force on q due to plus q and force on q due to q, that should be 0, clear. So here in this particular case what will be the force, okay, here in this particular case what will be the force over here. So force on okay, let me just here, so here force on q due to plus q plus force on q due to q, that should be 0. So what is the force on q due to capital Q, clear. So it will be k q divided by distance of separation is x, so it will be x square, plus force on q due to q, that will be k q into q divided by distance of separation is 2x whole square, that should be 0. So finally over here how can you write this one, k q into q divided by x square equal to negative of k q square upon 4x square, k q, k1 q will get cancelled out, x square and x square will get cancelled out. So finally how much we are getting, so q equal to minus q by 4. So finally that means the magnitude of unknown charge will be 1/4 times the magnitude of non charge, clear. And that should be of negative charge, clear. नेगेटिव साइन यहाँ पे क्या इंडिकेट करा है, ये एक नेगेटिव चार्ज यहाँ पर चाहिए. That means the ratio of these two charges q upon q will be equal to 1/4. इन दोनों का रेशियो यहाँ पे कितना होगा, -1/4. So option यहाँ पे 1/4 minus option D will be the correct one. So moving to question number 33. Here 4-point charges are placed at the corners of a square ABCD of side 10 cm as shown in figure. The force on a charge of 1 microcoulomb placed at the center of the square. So here a square ABCD is given over here and whose side is 10 centimeter. 10 centimeter. The force on a charge of 1 microcoulomb which is placed at the center. So at the center, suppose if we place a charge of 1 microcoulomb, then what will be the net force acting on that particular charge? Here it is asking. So here in this particular case, how will you solve this one? So just join each of the charges which are present at the corner of the square with the center charge. Clear? Center charge, but that means 1 microcoulomb charge. 1 microcoulomb charge को हम क्या करेंगे यहाँ पे बाकी सभी चार्जेस के साथ यहाँ पे जोड़ेंगे. Clear? So if we join them, so that will so if we join them, that will look like this here, like this. And here in this particular case, if we just see here, this 4 microcoulomb charge, this 4 microcoulomb, negative 4 microcoulomb charge will attract this 1 microcoulomb charge. Clear? Because unlike charges attract each other and it will attract it towards it. Clear? ये इस तरफ इसको attract करेगा. Clear? And this negative 4 microcoulomb charge which is located at B पर जो negative charge है 4 microcoulomb, that will also attract this 1 microcoulomb charge because unlike charges attract each other, and both the charges will attract with same magnitude. That means both of them will cancel each other over here. Clear? Similarly, if we just look at these 3 microcoulomb charges which are present at A and C. A पर जो यहाँ पे 3 microcoulomb का charge होगा, that will repel this 1 microcoulomb charge away from it because over here like charges repel each other. Clear? And similarly here this 3 microcoulomb charge which is present at C, that will repel this 1 microcoulomb charge which is present at O away from it with some force, and these two forces will be equal in magnitude and opposite direction. That means these two forces will again cancel out each other. That means here in this particular case the net force on 1 microcoulomb charge placed at the center, that will be net force will be how much? Net force will be 0. So over here net force will become 0. So option D will be the correct one. Okay, so here in question number 34, what it is saying is that 3 charges of equal magnitude Q are placed at the vertices of an equilateral triangle of side L. The force on a charge Q placed at the centroid of the triangle is. So here what it is saying, there is an equilateral triangle. Let this be an equilateral triangle whose all sides are equal, and the side is given to be as L. Clear? So here in this particular case the charges are Q, Q and Q are placed at the vertices of the given triangle, and there is a charge capital Q which is placed at the centroid of the given triangles. Let the centroid be present over here and the centroid be indicated by O, and a charge Q and a charge Q is present over here. Clear? So that means if we draw a perpendicular from the vertices of the given triangle, then it will pass through the centroid of the given triangle. So the vertices from the given triangle, if we draw the vertices from the all from all the vertices, if you draw perpendicular from all the vertices, then all the perpendiculars will pass through the centroid of the given triangle. So here in this particular case, if we draw one perpendicular from this particular charge Q, then that will cross the centroid, and from here also it will pass through the centroid. Here, So this is the centroid of the given triangle. Okay, right now here what is asking, so what will the net force on this particular charge q which is present on the centroid? So how will you calculate that one? So in that particular case we will apply the Coulombic force, and Coulomb's law is nothing but k q1 q2 divided by r square. So here important is that we know the magnitude of charges, but we don't know the distance of separation between them. So if we calculate one, then it will be applicable to other two. Clear? So first of all, what will be the distance between these two charges? ये वाला distance यहाँ पे कितना होगा, ये हमें calculate करना है. Clear? So वर्टेक्स से सेंट्रोइड का जो डिस्टेंस होता है वो कितना होता है. तो इस वाले पर्टिकुलर केस में हमें क्या करना है? So as we know, this total angle in case of an equilateral triangle is 60 degrees. So that means this perpendicular line will divide into equal half, so it will be 30 degree. Clear? So that means over here in this particular case, the perpendicular drawn from the vertex, वर्टेक्स जो यहाँ पे है उससे जो परपेंडिकुलर यहाँ पे ड्रॉ किया गया है इसका लेंथ यहाँ पे कितना होगा. क्लियर? सो हियर इन दिस पर्टिकुलर केस दैट वैल्यू, दैट परपेंडिकुलर वैल्यू विल बी हाउ मच? दैट विल बी सिंपली L cos 30 degree. Here how we are getting L cos 30 degree? Suppose here let it be a triangle is A, B and C, and let it be D. Clear? So here in this particular case how can we write that one? So AD will be equal to AB cos 30 degree. So AB is how much? AB is L. L cos 30 is root 3 by 2. So that means it will be root 3 L divided by 2. The value of AD is coming out to be root 3 L by 2. And another thing we know that this centroid of the given triangle, सेंट्रोइड जो है यहाँ पे ये जो परपेंडिकुलर है इसको कौन सा रेशियो में डिवाइड करता है? इसको 2:1 के रेशियो में यहाँ पे डिवाइड करता है. क्लियर? दैट मीन्स हियर इफ AD दिस परपेंडिकुलर इज root 3 L by 2, that means what will be the value of AO? The value of AO, A will be how much? 2/3. That means ये जो लाइन है, ये जो AO का जो डिस्टेंस है that will be 2/3 of the whole length AD. AO is 2/3 of AD, but AD is how much? AD is root 3 L divided by 2. So 2 got cancelled. So finally how much we are getting? We are getting L upon root 3. So we are getting L upon root 3. Clear? So finally here in this particular case we are getting this value to be, that means AO equal to BO equal to CO, that is equal to L upon root 3. ये यहाँ पे हमें डिस्टेंस मिल जा रहा है. क्लियर? तो डिस्टेंस बिटवीन द चार्ज which is present at the centroid and the charges which are present at the vertex. Now we'll calculate the force. So force on the Q charge, force on this particular charge due to the charge at A. So force on this Q charge due to the charge at A. A पे जो चार्ज है उसके वजह से फोर्स कितना होगा? So it will be KQQ divided by distance it's L upon root 3 square. So it will be 3 KQQ upon L square. तो इसका वैल्यू कितना होगा? 3 KQQ upon L square. Similarly the values of other two will be magnitude wise. Here we are calculating the force magnitude wise. And what will be its direction? इसका डायरेक्शन किस तरफ होगा? तो डायरेक्शन ऑफ दिस फोर्स ऑन द सेंट्रोइड चार्ज विल बी इन द डाउनवर्ड डायरेक्शन. ये नीचे की तरफ होगा ये. क्लियर? सिमिलरली what will be the force here in this particular case? Force on the centroid charge capital Q due to the charge at B, that will be same KQQ upon L upon root 3 whole square. So it will be 3 KQQ upon L square. Clear? And what will be the direction of that force? Direction of that force, ये जो B पे जो चार्ज है इसके वजह से इस चार्ज के ऊपर जो फोर्स होगा उसका डायरेक्शन किस तरफ होगा? That will be away from the charge and that will be directed along this direction. Clear? Next Similarly, what will be the force on this capital charge Q due to small q due to the charge at present at C? So it will be same 3k q upon L square, and its direction is important. So what will be the direction of that charge? ये जो q है यहाँ पे, ये इस चार्ज के ऊपर कौन सा डायरेक्शन में फोर्स अप्लाई करेगा? इट विल बी अप्लाइड अलोंग दिस पर्टिकुलर डायरेक्शन. ये डायरेक्शन में फोर्स अप्लाई कर रहा है. क्लियर? अच्छा. So here in this particular case we want to find out the net force. Net force central charge के ऊपर कितना होगा? तो इस केस में हम इसको डायरेक्टली ऐड नहीं कर सकते. We need to find out the resultant of these two charges. ये वाला जो चार्ज यहाँ पे, ये वाला जो फोर्स है और ये वाला जो फोर्स है, इन दोनों का रिजल्टेंट हमें यहाँ पे चाहिए. तो इन दोनों का रिजल्टेंट किस तरह होगा? दोनों का रिजल्टेंट हमें ये मिलेगा. क्लियर? सो व्हाट विल बी द रिजल्टेंट? अब इसको अगर हम एज्यूम करेंगे यहाँ पे, एज्यूम डेट दिस इज एफ एंड दिस इज एफ. ये दोनों फोर्स मान लो कि ऐसा है. क्लियर? ये दोनों फोर्सेस मान लो कि यहाँ पे ऐसा है, और इन दोनों के बीच में यहाँ पे एंगल कितना होगा? एंगल विल बी 120 डिग्री. क्लियर? बिकॉज ओवर हियर दिस इज 60, दिस पर्टिकुलर एंगल इज 60, दिस वन इज 60, so total is 120. This is f and this is f, so resultant of this one will be how much? So it will be resultant f prime, that will be equal to f square plus 2 into f into cos of 120 degree. Clear? So finally what will be that value? It will be 2f square plus 2f square, cos 120 is minus 1 by 2, so root of that one, so it will be f. It will be how much? It will be simply f. That means the resultant of these two forces will be how much? It will be simply f. How much will be getting? f if the angle between them is 120 degree. Clear? तो एंगल अगर यहाँ पे 120 हुआ तो रिजल्टेंट कितना आ रहा है? f आ रहा है. क्लियर? दैट मीन्स हियर इन दिस पर्टिकुलर केस, यहाँ पे अगर हम इसको देखेंगे तो जो फोर्सेस है वो किस तरह का है. क्लियर? तो ये जो सेंट्रोइड पे जो Q का चार्ज है, इस चार्ज के ऊपर डाउनवर्ड डायरेक्शन में एक फोर्स है, वो F है, और इस चार्ज के ऊपर एक फोर्स इस तरीके का है और एक फोर्स इस तरीके का है. ये F है, ये F है, और उन दोनों का रिजल्टेंट जो है वो यहाँ पे कितना मिला हम लोगों को? दैट इज F over here. So that means here in this particular case, these two forces are having same magnitude but directed in opposite direction. That means they will cancel out each other. That means here in this particular case, the net force acting on the central charge will be how much? Net force will be simply 0. Clear? So option D will be the correct one.